there are other ways to obtain data, and so we have to be sensitive to these kinds of issues when we talk about how we might protect the data from disclosing sensitive information. And one of them is time-based inferences. So if I know something about a corporation that, for instance, they're about to hire a manager in a particular division, if I ask for total salaries in that division, and then I ask for total salaries in a day, and I know that that event has happened, I can back into that information without ever asking for that piece of data. So I can't lock salary information. That is not, you can't lock it and still say that you protected it, because there's time-based inferences that I can make, particularly if I know about internal workings at the firm. And basically, if you think of these big sets, if I can ask enough queries, that what are the salaries of everybody in the department, what are the salaries of people who are over 40, what are the salaries of people under 35, and so on. If I can ask enough of those queries without ever getting a single asking for the salary of the the CEO or something like that, I can back into it. And clearly, in corporate disclosures, we are assisted by knowledge about the firm. That is, it's not a general statistical database where values are sort of evenly distributed, normally distributed around a mean. There are some very specific kinds of distributions. For instance, on salaries. Salaries, we're not going to have any salaries in this company that are less than $40,000. So immediately I know tails of distributions that help you understand what's going on. The other thing is, for instance, if I ask for means in departments, I know something about the sizes of departments. Or if I ask for the total salaries in the department, and I ask for mean, and you can figure out what the individuals are and so on, because I do have knowledge that department is not going to have 10,000 people, it's probably not going to have one person, so I can get some other information from that. So the problem that we have when we talk about secure queries and disclosure on websites and securing that is we have to approach it from restricting knowledge as opposed to data. I have to say I want to restrict what you're about to know as opposed to you can't have that field. So traditional approaches of locking data around fields is going to be a problem if that's the only approach that you have. You have to say, I don't want you to know this, as opposed to, I don't want you to have that piece of data. And so there are ways that we can restrict that. There are some approaches, and some of these come from the statistical database theory. But we have to, again, I said definition of sensitive information, and it may not be, I don't want you to know that salary, or I don't want you to know when I'm about to purchase that particular raw material. It may be a confidence interval around it. So I have to identify confidence intervals. Is it okay, excuse me, if I know that you're purchasing, titanium for your project within a week? Is that okay, or do I have to only know the day that you're about to purchase it? What is the confidence interval around that? And I can restrict sizes of results too, which is sort of gets at the individual salary information. And usually you can set N as the total number of records in your database, and K as some minimum number. So I can restrict queries that result in numbers of results outside of that range. So I'm not going to give you answers where there's only 2 entries in that, or over X number, whatever that is. And again, we have the inability to perturb that data. That is, if you ask for sales, I can't say, well, I'm going to multiply it by 40,000 or something like that, so that you won't really get the correct information. Now, there's another approach, and this is more of a statistical one, that I can do samples of database to preserve certain relationships. Basically, this is, if I project certain database states, I can keep in that projection of that database state, if I restrict certain values, so I can keep the managers out of it. There are certain properties that remain consistent if I do the correct projection. And if I do the correct projection, I can preserve information about that is valid for certain types of queries. Other types will not be valid, and that's one of the proofs that you have to decide is exactly what type of query you're supporting. But the approach that we're using right now, that I'm looking at right now, is tracking of disclosures, tracking of information that's disclosed. There are a couple of approaches to that. One that is suggested in the, that has been used, and this is computationally easier. Problem is, and I'll explain some of the problems with that, but they talk about what are called inference channels, where you have to identify paths to certain pieces of information. So you have to, one, you have to identify the sensitive information, manager's salary, and then you have to identify all the information that you need along that path to come up with that. So you just say you need to know this first, this, and so on. Now we encrypt tokens and we assign them, and they're required to traverse the path. So user gets X number of tokens, and in fact, N, right? N minus 1 tokens. You get N minus 1 tokens, so you can never traverse the entire path. As you get further down the path, you've lost your tokens, and the response would be, I can't respond to that information. It turns out that you also, in the way you respond to queries, has a lot to do with disclosing sensitive information, but that's sort of beyond what where I am right now. Served by blocking complete traversal of the channel. So you say, this is what you need to know to get to manager salaries. I keep you from that traversing that entire channel because you've used up all your tokens, essentially.
Well,
problems? Yep.
I just wanted to confirm that between the two capital N's is a hyphen.
Yeah,
and
it's
between
N
and a minus sign.
No, then there's the hyphen is big, the minus is small. Yep. Okay. So I have N minus 1, right? If it's a path of N, you get N minus 1. Here are some of the problems with it, that you now have to decide what's public information. And it's interesting that if you start, and I use this example to my students, and obviously since it's students I can use certain kind. Say, let's suppose that you went to a bar, okay? And they, oh, I've been there, so I know what you're talking about, okay? And someone sits down next to you and you're talking to them, and you know, and you don't know them, right? And they say, oh, you know, how you doing? Do you ever go on vacation? Yeah, I'm going on vacation next week. Oh, where do you live? Right. Well, immediately that red flag goes up. Well, I don't want that. I know they know I'm going on vacation, so I don't want to tell them where I live because, well, I don't know them, and I'm not going to allow that in there. So essentially, I've blocked that the ability to make that inference. However, and this is the problem, is that what if they reverse the question, right? Where do you live? You know, oh, I live. You know, oh, and the next question is, when are you going on vacation, right? You don't want, you know, so it's not which piece of information, it's the combination of those. That is, you traverse the entire channel. Now, you also have to worry about public information. Suppose, you know, I'm sitting at the bar, and I usually don't talk to students, but anyway, at bars, I try not to give them that option to bring into class that they saw me at the bar. But suppose that you had your something on you, you know, like you were a professor, or you made some comment earlier about where you live, you know, and they could infer that there was public information that professors live in this, you know, area of town or whatever. Now you have to worry that that public piece of information could be combined with the private information, and you could also traverse that channel. So that notion of public information, what is public information, where can you get it, and is it generally available? And so we talk about collusion-resistant token assignment, where we look at public tokens, so no one gets the token, you know, for that piece of information. We don't have to worry about it because everybody has it already, so I don't have to worry about assigning it. You ask about salaries in a particular department, but it's 2 months later, and I should, you know, salaries have changed. Now, depending again on what you're asking, there are certain parameters that may change. The mean of salaries may not change. Maybe that's it. Maybe the you know, the maximum might change or something like that. So you have to understand what are the parameters within that query of data that's been changing, and whether or not I should refund it. The implications. We have to understand goals, and I'm trying to build that into it right now, where we understand what the sensitive data is. And continuous reporting is going to support that, but we have to make sure that we understand that. For auditors, I think some of the implications are we have to, do managers now have to find sensitive information. Before, you could say, this is out of my realm. Management is going to find sensitive information. Can auditors say, no, that's not sensitive, or you can ask for it in certain characteristics of it. You can ask, they should be able to provide it within a confidence interval of a certain level. The implications for each of the query reporting characteristics, you know, time lags obviously have a big issue on those. And then again, that we're looking now more at knowledge security as opposed to data security. That I will not tell you where I live as opposed to I won't give you that piece of data. And I think that's a very different approach. Thank you.